I spent my weekend wrestling with a little side project, just me and a few hundred lines of Python.
Right.
And I still managed to completely lose track of the database logic. It's almost embarrassing how quickly things spiral for just one person.
Well, now imagine trying to manage thousands of coders at once.
Exactly, which is what Wilson Lin and the team at Cursor just did. It's an incredible contrast.
It is. They built a system where thousands of AI agents work together to build a functional web browser completely from scratch.
And they did it in just 1 week. We're talking something like 1,000 commits an hour.
1,000 an hour. It's wild.
So for today's deep dive, we're unpacking their paper towards self-driving code bases. The browser is the flashy headline, but the real story here is, how did they organize that digital workforce without it descending into chaos?
Well, it wasn't easy. In fact, their first couple of attempts were pretty spectacular failures.
Okay, so where did they start?
They started with what you might call the single genius model, just one huge agent, Opus 4.5, trying to hold the entire project plan in its head.
That feels doomed from the start. Was it just not smart enough?
It wasn't an intelligence problem, really. It was a scope problem. The agent was kind of like a junior engineer with no manager. It would just hallucinate progress. It would declare success when the code was completely broken because its short-term memory, its context window was just overflowing.
So step 2 was probably to add more agents, but that led to the bureaucracy phase, right?
Correct. They tried using a shared coordination file. Imagine 20 engineers all fighting for the same marker to write on one single whiteboard.
A total bottleneck.
Exactly. They spent more time waiting for locks, permission to write to the file than actually coding. Throughput just tanked.
So the single brain got overwhelmed, and the big committee just got gridlocked. What finally broke the jam?
They moved to a recursive hierarchy, and it looks almost exactly like a traditional corporate org chart.
Okay, so you've got a route planner at the top.
Yep. A route planner delegates to subplanners, who then delegate tasks out to the workers.
That sounds simple enough, but the magic has to be in the details. How does that structure solve the memory problem that killed the first attempt?
Isolation. That is the critical insight here. The workers are totally isolated from each other. So if a worker's job is to fix a UI button, it only sees the code relevant to that one button. It doesn't know anything about the database, and it doesn't need to.
So you're compartmentalizing the complexity. You're not forcing one AI to hold the entire blueprint in its head.
Precisely. It keeps them from getting confused by the sheer scale of the code base.
That's a brilliant solution if you can build an agent army from scratch.
Sure.
But for businesses that need to scale intelligence right now, that seems daunting.
Right, and that's where a company like Embersilk can really help.
They help you bypass that whole experimental phase.
Exactly. Whether it's AI training, software development, or just figuring out where agents could fit into your business, they help you get there faster.
You can check them out at embersilk.com to get your AI strategy moving. So back to Cursor. Once they had this hierarchy, you'd think the goal was perfect code every time.
You would, but that assumption actually broke the system again.
Really? Oh.
When they demanded 100% correctness for every single commit, the whole assembly line just froze.
So it's calculated chaos. You have to accept a little bit of breakage just to keep things moving.
Exactly. They allowed for slack. If one agent broke the build, they trusted the system was fast enough that another agent would spot it and fix it almost immediately.
Speed with quick corrections beats slow perfection.
By a long shot.
Now, speaking of speed, I would have guessed the bottleneck here was the AI's processing power.
Surprisingly, no. The limit wasn't intelligence, it was old-fashioned physics.
Right.
Specifically, disk I/O.
The hard drives couldn't keep up.
It was a traffic jam. These agents were generating something like 150 gigabytes of logs. The physical hard drives literally could not spin fast enough to write down everything the AI was doing.
That really puts the scale of this into perspective. The bottleneck isn't the speed of thought, it's the speed of writing to a disk.
Yep. And this whole hierarchy only worked because the managers knew how to prompt the workers.
The prompting strategy.
This was another key finding. They learned that treating the AI like a junior engineer fails. You don't tell a brilliant new hire how to write a test.
You just tell them what you need. It's constraints over instructions.
Yes. Instead of saying write good code, you say write code with no 2DOs left behind. And being specific with numbers helps.
How so?
Telling a subplanner to generate 20 to 100 tasks got much better results than a vague command like generate many tasks. It sets a clear, ambitious scope.
It's all fascinating because it feels like it circles back to Conway's law, the idea that systems end up mirroring the organizations that build them.
And that's the big aha moment of the whole project. This recursive structure, this hierarchy, it wasn't explicitly trained into the models. It was an emergent behavior.
It
It just happened. The most efficient way for all these digital minds to collaborate turned out to look exactly like a successful human engineering team.
which kind of recontextualizes how we work. We think we design our organizations, but maybe there are just fundamental patterns for solving complex problems.
It really makes you wonder.
Yeah, if efficiency always converges on this kind of structure, hierarchy, delegation, isolation, it suggests our human systems might not just be arbitrary, they might be the universal answer.
It's a hopeful thought that whether we're biological or digital, we're all stumbling toward the same fundamental truths about collaboration.
A great sign that we're on the right path. If you enjoyed this deep dive, please subscribe to the show.
Yeah.
Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.